on. Just a couple of slides to say who Inca are. Inca Digital Printers is a medium-sized company with about 150 employees based in Cambridge, England. This is our R&D labs. Well, maybe not. We're now part of what was formerly the Dai-Nippon Screen Group, but we operate as an independent business unit. For the past few years, since about 2002, in fact, we've been making large format flatbed printers for the point-of-sale graphics market. So what do I do? My job title is project manager, but I'm not very good at that. What I am principally is a system architect. I design inkjet printers, and then I do get to have to manage them from the R&D level all the way into production. And today I'm going to be talking mostly about a project I've been working on for a few years now, to design a print engine based around the Fujifilm Dymatics Samba printhead. Inca started a program to develop a print engine business based upon this printhead technology. So part of the reason I'm here today is to publicize that that's what we're about to do, and also to warn you about the terrible problems that anybody embarking on a single pass printer has to encounter and overcome. The first instance of an industrial cooperation between Inca as a print engine provider and an industrial partner, the announcement of this was made at Drupa this year, where an agreement between our parent company, Screen, and BHS Corrugated, who are based in Germany, there's an agreement there that we shall work with them to develop a printer using this print technology. Okay, so how difficult is it to make an inkjet printer? You can buy inkjet printers at the shops for $60 or something. So, well, it's not too difficult to design a reasonably small printer. This thing here, you can start by designing electronics boards, an ink system and mounts for the print heads. And actually, Inca's got a little stand here, and you can see this core print engine bit sitting on the stand. It's quite a human scale thing, quite a nice thing to handle. And you can put 4 or 5 of these together over a web transport, and you have a printer. What we set out to do, however, was much more foolish. We decided we wanted to make a print architecture which was scalable to much larger lengths. And we've recently started building one of these. And it's a bit hard to get the impression merely from photographs, but this thing here is 1.6 meters long. This is one print bar for one color. So we have 4 colors and huge electrical cabinets with the color bars over here. So it's a much bigger engineering task logistically, and there are also some technical challenges. So I want to talk a bit about those as well. How long does it take? Well, I was asked in February 2013 to design a scalable single-pass printhead, a single-pass printer, and I decided to use the Samba printhead. And by October 2014, so some 18 months, a bit longer afterwards, that printer, which I just showed you up there, was printing 4 heads wide using all our own electronics and all our own ink system. So we were printing with that 2 years ago. So what have we been doing in the following 2 years? It's not sufficient to print. You have to have good print quality. And we spend the best part of a year improving the print quality. Also, part of print quality is having a printing process that works. And it took us quite a long time to get that working. And it's only once I've got that we could commit to build that very big machine I showed you. And then sometime this month, we hope to get the first ink down out of our 1.6 wide meter version. So I just want to point out, it's not a short-scale task making a full-scale inkjet printer, single-pass printer. And even once we got it printing, I still expect many painful months in order to get good print quality. Some of the challenges. The first and most horrible challenge is choosing a printhead. And the reason for this is that only once you've chosen the printhead can you start to design the rest of the system around it. So the whole architecture of the machine, the layout, and the electronics is affected by your printhead choice. And you don't really know whether it's a good choice until 3 years later when you're establishing print quality. So it really is, this is the big decision, the printhead choice. You've also got to not only get the printheads, you have to make hardware to support them. Basically, to get the ones and zeros into them in the correct order and in the correct timing. Now, there are many companies that provide data path hardware. I'll just mention a couple here which are local to Cambridge. One is TTP Meteor and the other is GIS. And if you're wanting to dip your toes into the water of single-pass printing or any printing, these are a very good way to get started quickly. Inca is more interested as a system integrator in making these larger systems. So although we might start with off-the-shelf electronics, pretty soon we will set out to design our own circuit boards. And these allow us to put other features on, such as controls for motors, which a standard data path boards wouldn't have. So some way or other, you've got to get the data into it. You also have got to get the ink to it. And again, there are companies around, a couple of local ones in Cambridge, GIS and Megnajet, who provide ink supplies for circulating and non-recirculating printheads. Once again, being engineers, we like to reinvent the wheel a lot, and for a bigger system, this is a picture of our laboratory prototype of our 1.6 meter long ink supply. And there are several things in the design of this which have been thought about in the context of serviceability as well. So again, Inca tends to redesign everything. A lesson we have learnt from our flatbed printing business is the importance of serviceability and maintenance. In order to have a high uptime, which is essential for single-pass printing, we really need to focus quite hard early on in the design on how printheads are going to be adjusted and replaced and things like that. On a large system, it can be quite difficult to gain access to the printheads by hand. So we made the decision early on for the printhead mount for our Samba-based print engine, we would actually provide stepper motors to do the adjustment. This is expensive, but in terms of ease of use and servicing, we thought it was worth the extra money. Another very important thing you must worry about early on in the design is cleaning printheads. You shouldn't think of cleaning and maintaining printheads as an afterthought. It's important to get it into the system design right at the beginning. And we have our own designs of cleaning stations. We think that it's better to have a machine cleaning it because it's more controlled. If you leave it to a human being, unless they're a very highly trained person, they could well damage the printheads. So automated cleaning is important. Okay, so assuming we've got the print engine to send out drops of ink in the right time, and the substrate transport to move the substrate under the printheads, we've not really started on making a printer that produces good quality print. The most important thing is the print process, which is all about how the inks behave on the substrate. Can you get good, crisp text? Do you get too much intercolor bleed? Here's a typical, on the right-hand side, that's a snip from the Fogra test image for color bleed. And you can see here on the left-hand side, we have what I would say is a good cyan ink, which is producing reasonably sharp boundaries with a little bleed into the magenta. And here we have a not-so-good cyan ink. You don't really know this until you start printing. You can't print inks on top of inks without some sort of printing machine. And this is the key thing to getting commercially acceptable print quality. You've got to worry about the print process. If you're using water-based inks, part of the print process is drying them. And that might feed back into the formulation of the inks. So it's a difficult task to get that right. And this is the sort of take-home message I really want to get over. It is the print process that determines the layout of the machine. So you can't design your machine until you've got a print process. Otherwise, you might end up designing the wrong machine. Okay, some other more mundane but necessary things you'll need to get right if you decide to make your own single-pass print engine. If you take an image, which in this case is a series of step density bands, and you print it through 4 print heads, you may well get a pattern looking like this, where one print head is darker, and one region of one other print head is lighter than another region. And given that you intended that to come out, this isn't a very good result. Fortunately, these effects tend to be stable in time, or reasonably stable. So if you can measure it, you can adjust the data you send to the print heads so that where the printer is printing dark, you lighten the image. Where the image is printing light, you darken it, so that when you pass that image through print heads which do this, you get that. And the keen-eyed people here might notice there's still a little band here. But of course, what you can do is have another go and keep going around the loop till you get it right. Another thing you will find is that not every nozzle in every print head works every second of every day. You do get missing nozzles in print heads, either because of contamination in the ink, failure of the print head, or most likely contamination build-up from the substrate. So you need to be able to detect this, measure it, and correct for it. You'll also find that different print heads fire the drops at different speeds, so they don't land in the right position with respect to each other, so you have to correct for that. And finally, all print heads produce the main drop which lands on the paper, and tiny little satellite drops which don't, and which go everywhere. And in a machine which is consuming a lot of ink, you will produce a lot of satellites, and you need to mop those up. So that's a bit about the sort of machine side of it. As I suggested, the print process just doesn't work first time. So somebody needs to develop the print process. So it's important to have an ink partner who has all the facilities to do as much testing within the laboratory as they can. And then, when you start to print with it, that they're very responsive so they can change the formulation of the ink based upon the printing tests that are done. Ideally, you want a sort of an ink company which has a good applications department, so they're responsive as a small company, and yet they're big enough that they can scale to volume production when the product comes to market. We have some non-technical challenges as well. A big industrial single-pass printer is a very large undertaking, both in terms of money and resources. And the commercial agreements which need to be put in place are important and need to be considered right at the start. And the project management of these projects is difficult because they involve several partners, printhead people, ink manufacturers, system integrators. So the entire management of this is quite difficult. Okay, so finally, this is Nick Campbell's recipe for how to make a large-scale single-pass printer. The first thing is know what you're getting into. You're going to be spending a lot of that initially. It's a big task. Also, it's quite wise to make sure that there will be a market for what you're building before you spend all that money. Inkjet inks are traditionally used in relatively small volumes and are quite expensive. They might be $50 a litre. That's fine if you're not using a lot of it. But if you're trying to penetrate a market of industrial scale, you need to be thinking about an ink development which will be able to be getting closer to $10 a litre. It's no use using expensive ingredients from the outset if you don't think you can scale up to a lower cost route. So get the economics of the ink right as well before you spend the big money. As far as possible, you don't want to make your big printer until you're confident that the print process is right. So you should do that with small-scale equipment. What we did, and I'd recommend this, is to build a flexible prototype printer where you can adjust the gaps between the colors. You can put different sorts of drying or pinning between the colors. Something that allows you to experiment. Only once you've got the print process right do you then have enough information to go ahead. So by the time you've used your prototype printer, you should be producing print samples where your end users say, that's a good enough print. Only then do you start designing and building the big system. This makes the development a very long and drawn-out process, but at least it gives you some confidence that at the end you'll have something which is saleable. Okay. So, more or less to wind up, I think, Inca's main aims in the present situation is we want to bring this high-speed inkjet printing to industrial applications. But we realize we know nothing about industrial applications. We're engineers, we make printers. So we recognize we need to do this in partnership with people who understand the end-user market and who have access to that market. And we've made a lot of print engines in our time, and we believe that our experience can accelerate time to market by allowing you to avoid some of the mistakes we have made on your behalf in the past. We understand the importance and the difficulty of print process development, and we're able to help with that. But don't kid yourself. If you are going to embark on developing a single-pass printer, it's a difficult and costly and painful business. But the rewards are there at the end, and we can help you. How do I do that?